right? So we did with that. Here's some, right? Here's cosine. Right? So what does sine plus cosine look like? Well, what you do with that is you add 0 and 1 for the first point. Right? Here's cosine. Here's right? And say the superposition of those, we call it interference. We call it, in this case, for adding, we call it constructive interference. Doesn't remember that? So 1 plus 0 is 1. So if we're trying to do that, and if we add those are 3 over 2 or something like that. Yeah, those are somewhere here. Right? Here. We constructed the addition of these two functions. So we did this in trigonometry. I don't want to, tell you to pull that tomorrow in class. It'll be a little cleaner looking, but we've done that before. So that's what's going on here. Now, what suppose, we're going to start out very abstract. Suppose that this system is actually twice as likely to be in this position as that position. Okay? And that's what this question is all about. And you won't tell me think about it, right? Just by sort of backing away through it. But I'll look at it later too. There's a formal issue or a real substance probably. But that's what this is. It's twice as likely to do that. So we're going to do like a weighted average for this. So take the average of say so I'll use H because it's most way energy, right? So the average energy is going to be the average of these three, right? But a particular measurement is only going to be one of them. It's twice as likely to be that as this. That's what's going on. Is that helpful? Wait, that's okay. If you haven't, let me say it again. I'm glad you have. So when we've been up to this point, we've been dealing with really simple. They're not that simple. They're scary looking, but it's just calculus, right? But we one term. So we wait for the box. That's the way folks get the variable, right? We've been doing this one dimensional. So it's only one term here. It's a complicated term, but when I say one term, there would be a plus sign or a minus sign, there's more than one term. Okay. I'm using this term the way your math professors use it. Okay, so there are two terms here. So that means that any one measurement, it's complicated. Any one measurement might be phi2, might be phi1. And it's twice as likely to be phi1 as 2 because I defined it as that. So the problem that we have here, okay, yes, is this being recorded? Yes. Great. Okay, great. Yeah.
There's two different ones that are similar to that one.
This is, yeah, I'm sorry. This can you running the board. So function x is 11 over 4 plus 1/4 2 plus 1/2. Okay. And then normalized. And these are all normalized. This is normalized function. That's normalized function. That's normalized function. Yeah, the whole integral. of any function times its conjugate, its complex conjugate, right, has to be equal 1. That's what normalized means. And it's important. It's conceptually important, so I can't say it's not. This is also sort of important, but there's a lot of things we can get out. Normalized. That means that we talked about what normalization means. And they can each have their own eigenvalues. The eigenvalue for this one is E1. Okay, thank you. That's the question. Well, actually, the question is, this would be a decent question. I don't remember how the question goes. What's the average, or what's the expectation value of the energy? Right. By the way, the expectation value goes like you're going to imagine it to go. If we say, let's take a citizen of the United States. We take a citizen of the United States. What's the expected value for their age? Right. So how do you do that? You do a weighted average. If the age we're talking about is integers, we're not going to say 2.5 or 3.5 or 52.5. We're going to say 52 or 22 or whatever, right? So in that case, we're going to do a weighted average. We're going to count up all the 52-year-olds. We're going to count up all the 51-year-olds. We're going to count up all the 2-year-olds and all this. Does that make sense? What's the expectation value? And so the expectation value then is actually going to be, in that case, the expectation value is going to be somewhere in the middle, right? But if we say now, that's what this is. What's the average? What's the expectation value? If you take a citizen of the United States, what do you? Now, obviously, you don't say it with great confidence because there's right. It's the average. Okay? If you say you take a measurement of a citizen of the United States, what are you going to find? Right? If half, can I make up a certain example? If half of the citizens of the United States were 53 years old, you say, well, there's no 50% chance you need 52, right? But you know that if I took a measurement of an age of a person in the United States and found it was 2, wouldn't surprise you, right? Wouldn't surprise you at all. It would have been 42. Make it individual measurement. Individual measurement, right? And this is the sort of what we typically think of the expectation value. I think the language in this question was something like, suppose you take a bunch of measurements, right? Let's go back to this problem then, having sort of defined those two terms. What is a possible value of a measurement? Right? Or 2D1. So, but then what's the expectation value? The expectation value is the average. Now, which of these is that is most weighted? Yeah, I think so. Yeah, that's the biggest weight. Right? Wait, can you read the question now? Now that we've got that, I think there were 2 questions that come out of this one. Okay.
It's do you know the probability, or what is it?
Right.
What are the possible values of the kinetic energy that can be observed in the measurement? So it gave us like a list of 1 plus 2, 61. It's asking.
Yeah, these are the only possible observed values, right? That's the only ones you can choose, right? The age of the population. Now, this is a little bit. Our analogy breaks down a little bit. Suppose, and you can imagine the population that you had no 14-year-olds. It might be no 14-year-olds, but the average could be 14, right? So you might find that all 15-year-olds and 13-year-olds. Why would you get a bunch of 15 scales in a room? We know 14. But it could be 14, but we never find an instance of 14. That's what that's right.
But not like 2.
That's right. It's not that. Yeah. Because any individual measurement. So that question's about what individual measurements could you find? That helpful? I implore you. You all are the ones that are here. There's a simple story here behind it. And when you explain it to them, you'll get it better. So tell your classmates, maybe tonight in lab, they study this again. Sorry. So maybe tomorrow night in lab, we can study for this also. We can find somebody who's asking about it and rush over to the kid and explain it. When you do, you get it better.
I know you already answered it, but as you just know probability of measuring the equation. So it was a first one. So what I just add on these.
What's the expectation value? Expectation value. So, well, let me take a minute. I don't have any notes here with me. I was so happy with that. Again, the board the other day that I used that term. When am I going to learn? You know. Anyway, but I don't have notes for this, so I'm going to write some risk. And I'm going to do it. So you know. Yeah, good. Okay, so if that's true, we can run this out, and it's actually. And the question is, what's the expectation value, right?
Yes.
So let's do it. Let's say it is. Okay, right? That. It's a right. So root 11 over 4. So right? That's that. Or 11. Right? Side 1 squared. Agreed? Got it in notes. It's orthogonal. So the orthogonal. Okay. So in the end, it's gonna really save a lot of trouble for us. Practice enough, you never really have to understand it. But side 1 times side 2 is 0. This does come up in another question from set 2. All right, but if it's 2, if you have two-way functions. I'm gonna call that side 1. Side 1. Yes, this is 0. So now I can see, since I know that goes to 0, and this goes to 11 side 1 squared. And I can just, I can keep the rest of the math on this and do it. Two, one, one, four. So this is one. They have to do that. Yeah, that's one goal, exactly. So this ends up being, and this is all ones, right? 11, 16, 1. You can now see how these are. This it's a little less. It's the weighted average ones up here, right? So this is three, and it goes like this. Since it's at, we can add. Would you read the questions we did?
What is the expectation value or athlete?
16 times this, plus 11, plus 1 times that. E1 plus. We do it. 4, E1. Okay. So this is also it's 11, E1 plus 2, E1 plus 16. 1. And helpful.
The acceptable, weight. Thought that the one that would not be acceptable. Which is when I ordered.
I ranked this year. I haven't done this over here. Where's that? We're gonna get that on. Where's it's also possible. I'll forget something, right? That was the real thing. The real disaster. So I'll put something on that. What you wouldn't be on. Right? So yeah, my sake. Anyhow, so the student says, what makes sense here, right? Doesn't necessarily have to. Okay, what's an acceptable? We have like 2 rules for acceptable wave functions. They have to be single valued and continuous, I think, right? So the question is, what's the this is question 7. What's the acceptable wave function over the indicated interval? So the first one is x squared plus 1. And I think the first time I got this one wrong first time because I wasn't paying attention, but there's no interval. I think this is gonna be like that. I think, let's go look at it, okay? But this one. We'll talk about one. And I suppose I think you're right, you know. Talk about it, but. There's no interval here. So I think the way the question is sorted is. This one's got an interval. So Esperanza said, well, wait, that's 4. And this is nonsense, right? This is undefined. 4. So this one. Is that one?
And make it like a finite. If it's not on the interval, you just have to say it's on.
I think because the way the question's worded over the given interval. What's that? Do you want to give me one? Yeah. So. Yeah, just have to. I'll look up it, see if we can get a good definition. Give me that one. That's the one. I think here's one. E to the minus x, and it's over the interval negative infinity. Yeah, and I think this is. I think the problem with this one is. Is that what it is? Okay. I think the problem with this one is if we integrate this. Let me we're gonna find is that that's where the integral is you give us an error function. It's not integratable over that. That's the reason why. So I'm not saying it. Give me one more second. Let me write this. Where's so if we do the integral of this. It's I can review myself. What I'm going to do is I'm going to integrate this. I think we're going to find we get. can't switch this way. See. You do the next one ready? Right. Reason I'm not, 20 minutes.
I was actually this one. The question I had. This one.
You want me to do an I can.
Overview is fine, it says this expert.
So yeah, that's randomization also. Questions. So can you
Function of the operator. Operator is equal to x squared over 8 b squared.
let's do a couple of these. These would be great practice. Question is, if this is this, right? I'm not. So x squared over 8. B. When I do this, I wonder when I'm doing this in front of class, when people follow what I'm doing. So I think I'm doing it the clearest way. But what I'm going to do is I'm going to write this out here. And I'm going to say d. This time I'm going to write it out twice. d dx, right, of x squared. So all I've done is written the same thing twice. And I'm doing this because I trust myself. No. So this is x squared over 8 d dx. And then the derivative of that is 2x, right? And I'm going to leave that 2 there for now. Right? This then becomes 4x squared over 8. That's it, right? So this is f. Right? So the question is, f. So it's an eigenfunction of an operator. Actually, yeah. Right, so effective on that.
I'm having trouble identifying how to identify eigenvalue.
Let me do the board work a little more carefully. We'll do it several times today. If tomorrow you're not comfortable with it, say it again. We'll do it again. Close to understanding. Okay? And I'm going to organize the board work a little more carefully. How much? Right? I wonder, well, how often I'm hiding because it's so scary. So I'm so glad you said something. Okay. So. Sorry. Sorry about that. I can feel it now. I don't want to stall. Thank you. My handwriting was beautiful when I was 30 years old. It's just going, by the time I'm 60, it's just gonna be. Eigenfunction, eigenvalue, this is not any logical order, right? It's just terms that we still see. Operator may be sort of there. Operator, am I missing something? So operators may use the notation of something with a hat. Functions use lots of different notation, okay? But we oftentimes use psi in physics, and phi might be a subset of psi. We use f, we use g, we use h. If we want to indicate something's a function, and we're usually like at the beginning of the explanation, we'll say we want to talk about some function. We're going to say it's actually a function of x. That means the next couple sentences they're going to be talking about x. Could have why. This we could also say this is the function. And that may not did bother me, but in some way I use side, and sometimes I say side. That can be confusing to some people. Maybe the right. So for example, if I do side dx, I'm saying it's a function of x because it wouldn't be interesting. It would be 0. It wasn't a function of x. Right. So sometimes I'll just leave it up there. I write something up there. I really want to say something because it's very likely we're not dealing with. It's also possible that handwriting is bad, or I've actually written something up there that I don't need. So that really, I do not want that to get in the way. We have enough hard work to do. Please raise your hand and say, "Dad, what's that mean?" Or "I didn't do." Or it turned out something. It was a definition, and just I wasted some time sweating. So we've got these terms here. Now we're going to which we define. Okay. Now, when we do that, we're going to now, if we can, out of that to that f hop, then we're going to say it's an eigen. Okay. Then that's a function. There's a function. Is this an eigenfunction of that operator? I don't know. If I can factor that out, it is. So one I did an example in class, and then I said I'll give you another one in lab, and I just never got sideways. Yeah. Let me give you an example now. I gave you later. Let's say we have some operator. Let's have two operators. Okay? O and two operators, and they are. So these are you okay what work right like that? This is that. That's that. So let's make a function. This one is I believe it. There's some function signs. Now is f an eigenfunction of the operator m? M hat. I'm gonna take our time with it and we go, okay, well, that's. Cosine. Can you factor sin x out of that? That is orthogonal. Yeah, right, we proved that a little bit ago. That's not, you cannot factor sin x out of that. There is no way to divide by sin x. Then f is, you use the language, you say it. No, you're close, you're close. You meant the right thing, just the same.
F is the eigenfunction, then the eigenvalue is the thing that's
Close.
Okay, so the function here is f.
If it were an eigenfunction, it would
If
be.
it were an eigenfunction, f would be
That's right.
an function.
That's right.
And then, since we can't see sign out, it's not an eigenvalue.
It's not an eigenfunction.
Eigenfunction.
and there is no eigenvalue.
Okay, and there is no eigenvalue because.
That's right.
Okay.
That's right. Listen, we need to keep doing it though. Yeah, I'm gonna ask you that again.
Do another one.
Okay? And we'll do another one. And we're gonna, you're not the only one.
No. I've been doing this in math for years after we teach text every single time.
Yeah, it's because it's weird, we don't do, you know? We do this every day. The other operator. Functions are eigenfunctions of operators. Or they're not. So is this function an eigenfunction of that operator? And if so, what's the eigenvalue? Yeah. And I know that is cosine x. Or here. So can I factor sine x out of this? Yes, I can. And so is this an eigenfunction of the operator O hat? Yes, it is. What's the eigenvalue? Yes. Exactly. Okay. So we may do this again today. Hopefully we'll do it again tonight. Stage this. Hopefully we'll do it again tomorrow. And if we do soon, if you like it, that I would say is like probably the best and the easiest. You know, there's one that's easier. I'll show you that one in a second. This is very close to the easiest of that question. So then what you need to do, if you like it, you need to add a feature to it. And I'll give you an example of a feature you would add to this. I'm now just teaching you seniors how to learn, which is maybe not appropriate, but it's okay. Well, operators. Let's do another operator. I'm going to call it. I'm going to call it T hat. This one is going to have 4 nothing to do with it. We will be able to. It's the second derivative. We will be able to function. We will be able to factor out sin x. But you just get this big in front of it. Just an ended exterior term. Okay. That maybe is over the top. I'm going to just put 4. Anything. Right? So. And the question is f an eigenfunction? Should let you say it. What will you say? Is it an eigenfunction? Yeah. 4. Right, just set myself up for. Okay, now I'm done operating on it. And so the question is, an eigenfunction. So I look at that. Can you find f in there? Can you find the original function? What is it?
The original function. Stop.
Yeah, yes, there it is right there. And everything else is the, that's right. That was a scary one. So before you practice that one again, just go back and redo these and say, you know, the easiest one I can think of is sort of the easiest, but it's this I pulled these when I think about class and figures. It was yeah. That easiest one is e to the x, right? E to the x. Later. Okay. An eigenfunction of O x. Take your time. Take your time. Yeah. Be patient with yourself. Take your time. If you get it wrong, it's way better to get it wrong than to not guess.
Our operators usually the.
No. I mean, maybe the ones we see will mostly be MDDX. But it's way more broad than that. Yeah.
I'm using an operator X and
Good.
have a thing to prove it out.
Really?
Yeah, because X times sine of X is X.
Hold that example, okay? I think that we have something there.
Yes.
It is why.
Because when.
Right. That's right. And then after the operator, right? So what's the eigenvalue? Yeah. Okay. So a student comes up, I think, with an example that is elegant in simplicity and still possibly a twister. So let's look at it, right? So this is what you should be doing. You're looking on the ground for the edges of the.
So they gave me the function as sine of X, and I chose the operator X.
Oh, okay. Thank you, partner. Okay. And so the question is this an eigen? You tell me, is this an eigenfunction? Is that an eigenfunction of O hat, right?
Yeah.
And so let's do it. Let's say that. Right? And we just have x, it's just a multiplication problem. So can I or sign x out of this? Yes. And so where's right there? And so what's the eigenvalue? X. Is that what you said?
Yeah, but it said I was wrong. Yeah, I put yes, and it said wrong. But you can
This
see
is
my
the
work.
homework problem?
Yeah.
Okay.
Yeah, I typed in yes.
Okay. All right. Big part. I likely catch that without a note from you because I'm going through and looking at them individually. But yeah, it is because we can then that's our eigenvalue.
Okay.
Good. Thank you for the warm. All right. Yeah, I'd like to drop that for now and move on to next. Because we talked about the simplest ones.
And the, stuff, so like anything you want to do, and like the ground state stuff, and it was stuff that was supplied with knowing
Sorry,
that
yeah.
chemistry stuff. Last time we took Gen Chem 2 and 2000. I've got 3 analytical chem because it's math.
Well, it helps that you know where you know, correct me too, is this problem set too?
Yes, for me, it's number, nope, hold on. Yes, I think it's 0.88 million atoms. So,
Box like this, right?
Yeah.
So at this point,
yes, 0.88.
yeah.
Number 10 has more.
I'm gonna put energy for the.
Daily squared.
So I have this other testing on. Actually, you can see why it would be good for the student if they had to have. And so, anyway, the reason I wouldn't have it there was. So the question says 0 point energy, the lowest energy you can possibly get. Okay, 0 in harmony.
Yeah.
Here, how many? And that's it. Okay, so over here, I'm gonna say like the last page of my exam, I've got all those constants. Or just don't ever worry about memorizing stuff like that. It sort of does help me relax. I haven't memorized, but I won't have memorized because I see it now. See, 0 point energy and is equal to 1. That's the lowest energy level possible. Can't have less than that. None, right? 1.
3.0. No. I'm so sorry. It's because it's you. I was like,
0.003. Okay. AMU. Okay.
Yeah.
Yeah. 1.0. AMU, which is equal to 0.602, you said? Yeah, and I do want to take the time for this, okay? Because students who did this wrong, first of all, I have any idea what to do, and it's class is big enough. But you are able to get it. You knew that this was what was going on. So bring that to meters. Right. Yeah, I'm gonna do it. I'll look at just immediately. I'm gonna write it down. I'm not gonna mess with it. Get all my things into yep. What is times 1.66 into the minus 27 equals 6.64.
Can you put the AMU conversion on the test? Because I'm not gonna do that.
Since I've got the answer here, I'm just going to do it. It's nice to get the. I'm going to say, this is my A course. So it's going to be. Which is one. In my younger days, or stage, there were times when I was just doing so well that I was quite relaxing. So I would do something. It's multiple choice. So I'm going to say 6.6. 2 divided by 8 is 0.25. I'm so proud of myself. Thank you. You say that's a square. Thank you.
And also, it's manipulation. So what do you think, 1 times 10 to the negative 4 pounds?
It's 1 times 10 to the negative
Oh,
square. Square. So you square that negative.
Yeah, all right. So yeah. No, yeah. Sure.
It took me a second.
I don't want to do it in this chapter. I'm going to do it instead. I'm just going to. You can't. You want to show you a tool you can't use in your exam, but it's great for study. Okay, good. It's great. What I use.
It's a big word.
So when I'm writing keys for these homework assignments, it's very important I get it right, right? Because so I've set up a spreadsheet, and so this was maybe number 11 in my problem. 13, number 13 when I did this one, okay? So I give you, this is probably not me, but I set up like that, and I put a formula in there, right? So that if I get another iteration and someone else's homework assignment, I can just go in and say, okay, they have a box at the 2 is set point. Right, just plug it in, and I don't have to mess around with putting in the calculator room. I don't do this estimation when I'm writing keys for your exams or homework. I don't do that. All right, so I'm going to go ahead and put these numbers in here now. This math is the same math, it's a human amount of the one I did. This was the same length, so this is the very one I did. All right, so I'm going to in the energy. So, yeah, I didn't really show you guys.
That's the same thing I just put on.
Is that helpful?
But I guess I don't need your word. Because for number 10, it says calculate the wavelength of light emitted when an electron is in the one makes the transition from n=7 state to n=6. So, oh, I guess no, there was another one where I was talking about the ground state, and it was like I felt like I just was supposed to know that 4 was the ground state, but I didn't know that. Not for me, but maybe it's for you. Yeah.
Oh, yeah. Okay. Yeah. This is good problem. So for this, so definitely. You see that problem. So,
Yeah.
but hopefully when you're done with it, you work right back. Okay, so this is simple that it looks. So. That's a triangle. Let me read the question.
This is all for me. So.
High network here. You have a bunch of electrons that are in the pi here. And or I mean, it would be possible, I think, for a student to, and this is what I'm asking you. I'm not asking you guys to remember organic chemistry. I'm basically saying, all right, what could this be asked, right? So use the particle in so actually, no, I'm saying. Bonds are 154. Double bond. Now all that up, and we're going to get.
Oh, my bad. I'm
Meters?
mixing up.
Is that the problem? I think femto is 15. Am I wrong?
I think. 10. Yeah.
Pico means it's a multiple four. Multiple three. It's either going to be -9, -12, -15. Nano is -9. Pico is.
I did too. I mean, it sounds good. But it's 7.1.
Perfect. Perfect. Right?
Yeah. Okay. Yes.
7.13, you said? Seven oh three. I thought you said 7.13. So the length then. Don't like it, let me know, because I could be happy to have it wrong.
That's probably good 3 times 153. And that's on the 7.13.
Wait, give those numbers again.
Maybe the length was 3 times 153. Plus.
Wait, give 153 there?
Or
That's-
130.
Weird, yeah, wait. 713, I agree with you. When my calculator, you just like. Oh, got it. They changed my guy. I looked it up. So the reason I got 7.03 or 7.04, so I got there, is because when the numbers didn't come out exactly like they did with the multiple choice, I went online and looked around a little bit and found that there are some people that say that with a high system, this is 154 is 154.
Right, so this is, because I found that 7.03 is what it was 135 and this is times 150.
Yeah. Well, that would be the, you get the same answer. Yeah. I got 704 because I changed that to 151. So I was in my spreadsheet to see what happened. Okay. But the question itself is 154. So this will give you that this is the same thing as 135 plus 135. Right? So it doesn't matter. And thank you. I'm glad you said something as well. When you were not smiling, I thought to myself, all right. Okay. So now that we have that, we're all good. Right. Let's figure it out. So it's a particle box. Two times, I mean, 3 times 1, 35. Because this is 135, another 135. So the overall length.
Okay,
That's from particle in a box.
okay.
Yeah, I don't think it's. I mean, there's times in my life and
Yeah, because that's what I was trying to think. I thought what the build value
yeah,
was.
yeah, because we're assuming this thing's linear, it's a particle, it's just a one-dimensional system here, and we've got an electron that we can. Uh, 6 electrons here in the ground state, but we want to excite one. So in order to excite one, it's going to have one solution. Next. You want to work it out or do you want to drop it? Okay. So then what that's going to be is really it's the delta. There's 2 ways we can do this. Now, I'm just going to bunch it out on the board, but it's okay. Over 8 and I use and then I say, you know what, I can factor all that stuff out here. It's gonna be so much easier if I can just I squared minus n. And this is asking for transition, so it's the actual value. So that's the way to, okay, so first we'll get you energy. Calculate. And that. Electron. 9.11, 10 to the minus 31. So that everyone wants to think I'm going to give you an exam. Tempted to notice this L, but change it to L if you don't mind. Link the box. Now just to tell you my conclusion. Are you okay with that? My conclusion is that the energy first of all. Keep your pencil handy or a calculator. Let's calculate this together and just practice to make sure we're all doing the same thing. Let's do.
That's the.
That's right. Yeah. One minus four. Negative. That's 9. Why don't I take this call? Hello. Hey, Gabriel. Sort of, sort of. Listen, you're calling on my computer. I think I gave your class my personal cell phone number, right? It doesn't matter, doesn't matter. If you want to get me, I'm not always on my computer, so if you want to get me and I'm not available, you can try my personal number, which I think I gave you in class. It's not on the syllabus, and it's not posted on the internet. Anyhow, what can I do for you? Yes, it is possible. If you review those topics, send me an email and say I have reviewed those topics. I'm gonna go on your reports. I'm gonna verify that you have reviewed them. Does that make sense? So after you have reviewed them, and I've verified that you reviewed them, in other words, I can see that you actually have practiced for it, and I'll reset it for you.
All right, and last two. The same syllabus that is not on.
Yes.
Okay. If I kind of like.
Let me look at your reports a little more carefully before I say something about that. I don't know. That's gonna, the quizzes have almost nothing to do with how possible it is for you to pass the class, right? Because they're not worth very much at all. It's the homework. That's killer. And the lab, of course, is killer too. And let me look at your reports a little bit and get back to you. Can I do that? Yes. After 2. Yep. You may call after 2. Are you going to be on campus? It'll be easier for me to describe this to you if we're actually in person. So you want to come to my office? No, actually, it's in the, I don't think you ever see me in the A building. You know where the A building is? Yeah, okay, go to the A building and then look for me. There's lots and lots of rooms in the A building, tons. It's a little hard to find me, so if you can't find me right away, call me or text me, and I'll walk you through it. You know where Chick-fil-A is? Yeah, that's the A building.
Okay.
So if you go to Chick-fil-A and walk down that back hallway, straight leave Chick-fil-A and just walk down that back hallway. When you get to the end of that hallway, you're pretty close to my office. So that's a hint of where it is, but that's not, you know, there's a couple turns you have to take. Anyways, let's talk about it around 2 o'clock. All right, Gabriel, talk to you soon. Bye-bye. Anybody get this number here? 1.22. All right. And if you're not getting this, then you're gonna miss some sort of I don't want to say easy points, but just some sort of trivial points, right? Just getting in your calculator correct. So, but nobody got it, so maybe I'm wrong. Let me do it now on the board. Yeah, yeah, that's why I don't want to use this, because if you don't get the order of operations right, it gives you the wrong thing. Let's do this. 6.626. Let's all do that. It's what you say again? This is dual squared. That's a squared. Now 8, of course. And then what do you have for now? 4.4. So far, I'm okay with that. That's at 6. I don't have a problem. Right, so let's do this. Instead of rounding. Let's go 4.39. Okay, all right. I know I can take one. Thank you. I'm glad you asked. All right, so here's the reason why. Yeah, here's the reason why. So if you the energy levels for these electrons. There's 6 pi electrons, right? And since there's 6 pi electrons, they're going to go into the lowest energy level, and the next lowest, and the next lowest. Okay? So what we do is excite something from the 3 to the 4. That's the reason why I was. And that was just, wasn't in my mind. Okay? So I was.
Have to multiply 3 to the first time.
So we were taking and initial is 3. And final is 4. Yeah. So it's A minus 9. This is so long now. Okay. So there are a lot of pi electrons right here, and the question is, you see some 2 pi electrons here, double bond, and one of them is sigma. 2 pi electrons, 2 pi electrons, 2 pi electrons. So there's 6 total. One of these from here to here. Yeah. If you use it as an exam, that's obviously good enough. But it's a way to sort of.
Very visually structured. So like I always to like little sections. So my actual work ends up being but
By the way, I just thought of something that would make, I hadn't thought of earlier in terms of question being harder on the exam than it is. Okay, there's a couple of reasons. Number one is because you're during the exam, you're not sitting there in your most favorite place, right? Another reason why is it's not multiple choice, right? It's not multiple choice, and I'm prepared for you that will be multiple choice. Like there's yeah, I'm just not for sure. So that would be hard. Because you can see with the multiple choice, because something wrong here, right? You can sort of feel for it and go back and do that. And anything. Yeah. Yeah, that this never came up in the conversation. I never thought so.
I feel like it was like once you're getting to a certain spot, like you can do
Yeah.
toss out and stuff, and
Yeah. That would be a downside, you're right. Therefore. Because you see, I'm. Right? And so what I think was this. A little bit of fun. I think I said we stay something, right? I'm prepared to stay a little longer. I can stay a little longer. I do need to give you the rest.